All right, lesson 9, the same but different. Here are two solids. What information would you need to calculate the volume of each solid? Well, here, volume is length times width times height. Not too bad. This one, a little bit harder. The volume is actually the area of the circle. That's sort of our length and width, times the height. So to get the area of the circle, I actually need to know the radius or the diameter. Because the area of a circle is pi r squared. And then the height of the circle. So the area of a cylinder is pi r squared times height. And then the area of a cube is length times width times height. What is the same and different about how you would find the volume of each solid? Well, they're different shapes, so we would need the radius of a circle. We still need the height. We need how tall it is, but it's different measurement as far as length and width goes. So here are two containers. All measurements are in centimeters. Suppose the prism contains water that reaches a height of 1 centimeter. So that's 10. Okay, 1 centimeter. 1 centimeter. Draw a representation of this situation. I did. I'm going to change that over there though. And let's make that an actual one. I should have made it blue. The water is poured from the prism into the cylinder. Oh wait, sorry. I didn't read this right. Okay, the prism is the thing on the right. Prism. The water is poured from the prism into the cylinder. What is the height of the water in the cylinder? Explain your reasoning. I'm not really sure. Because I don't know. I mean, it's going to be some height down here, but I'm not entirely sure, but we can figure it out, okay? So I'm moving this up. We have the same height here. Can we figure out what the area of the base is? Length times width, which is 4 pi, times 9, which is 36 pi. Now, what is the area of the base here? Pi r squared, which is, so the area of the base for both are 36 pi. The height is 10 for both, so this one is also going to be 1 centimeter. Because you're taking the same area 1 inch high, same area 1 inch high. In essence, the same volume is going to fit in the same space of the other one, same volume. What is the height? 1 centimeter. The reasoning is the math. Okay, we did the area of the bottom of the cube and the area of the bottom of the cylinder, and the areas are the same. Suppose the prism contained water that reached a height of 3 centimeters instead of 1 centimeter. If the water were poured into an empty cylinder, what would the height of the water in the cylinder be? The same. Okay, so the area of that bottom, so this was 36 pi, we're still on the prism, times 1 centimeter high is 36 pi. 36 pi, and that's volume. Sorry, this would be centimeters. 3, it's the same volume, but to me that doesn't matter. It's the same height up. If we pour that into the cylinder, it's going to be the area of the base times 3, same exact volume. It's going to go up the same height of the cylinder. because you're covering the same amount of area. Okay. Revisiting rotation. Suppose each two-dimensional figure is rotated around the vertical axis shown. Each small square in the grid represents 1 square centimeter. For each solid, either sketch or describe in words the three-dimensional solid that would form. Here, if I'm rotating it around, I'm going to, nope, sorry. But it's going to be circular at the bottom and circular at the top. So really, it's going to look something like this, right? And this one, I'm going to skip that open space, and it's going to be like this on the outside, right? So we're actually like this. Like a pipe, okay? Sketch or describe. It's a cylinder with a hole in it. I'd call it a pipe. And here I've got a funny shape. And really that should be, let's do this one again. That's a pretty bad one. Okay, would look like that on the top, straight down, straight over, circular, can really so those lines are bad. Look just like that, with no opening in it. Okay, now find the solid's volume. This is the fun part to me. It's like a puzzle. All right, so we want the volume of this one. Let's go in red. So really, if I found the volume of the outer cylinder and subtracted the volume of the inner cylinder, I would have the volume in between. So it's like we're taking the volume of the whole thing, like it's a solid, and then boring out the volume of the inside, cutting it out. All right, so the volume of the outside would be, remember, it's pi r squared times the height, with the radius here being 1, 2, 3, 4, 5. Times the height, 1, 2, 3, 4, 5, 6. So that's 25 times 6, which is 150, so 150 pi. We just leave the pi there. And the volume of the inner, which is radius 3, height 6. Oh, we'll put it here. So that is 9 times 6, which is 54. Now if we subtract those, we leave the pi, and we just subtract 150 minus 54, which is 96 pi units cubed. Here, this isn't normal either. We could either take the volume of the whole thing and subtract out this, or we can do the volume of this small one and plus the volume of this big one, which I like a little bit better. All right, so the volume of the small one plus the volume of the big one. So the volume of the small one is going to be pi, the radius is 2, and then the height is 3. So radius of 2, height of 3. So we're just doing the volume of this, but as it revolves around here, right? Times height, what did we say was 3? Plus the volume of the big one, which is pi, The radius of the big one is 2, 3, 4, 5. And the height is 3. So 4 times 3 is 12. 25 times 3 is 75. Goodness, I did it again. 75 pi. So 12 plus 75 is 87 pi units cubed. And that's the cool down. All right, these are hard. I've always thought they were fun, but they take practice. So don't give up on these. Try to find a shape that you can find the volume of, and you can add things together or subtract things from each other, and you'll get there. All right, good job.